Hello, welcome back. Last time I had a little bit of trouble with tag urits and didn't do well on any particular axis and also took a long time to get anything to happen. I want to take another quick look at this. So I had the thought right after I had finished this that perhaps the main thing that I was missing was SLX, since DX300 does communicate over XBus. So I thought, okay, I can just sleep until I get input from it. But then, just today, thinking about that further, I don't think that's going to be true because it will always just... If I try to sleep on a DX300, it's always just going to have data for me, isn't it? Because I was thinking, like, I'm doing a polling system here. Every tick, I check the state of every input and take action if necessary. But if I could do more of an event-driven system and just wait until there is a change in input, then I could be more efficient. The problem is, like, I'll bet I can't sleep on this at all because this is non-blocking. The data is always available, right? Does it say? Read from any XBus pin to get a 3-digit number that captures the state of the simple I/O pins. The digits resulting, whatever. Is there an easy, quick way I can test this? So like X0. I mean, okay, sure, let's just be silly and SLX on X0 here. Yeah, see, that doesn't sleep at all. There's always information coming in. So that's not going to do anything good. Alright, well that was my main idea, and anything else is going to require much more substantial changes to this puzzle. So I'm just going to set this down for now. Get a little more familiar with all these components somewhere else. Maybe I'll understand when I come back in like a month and see exactly what I did wrong here and do it much better. Anyway, cool dad! Check it out, it's from Joe. Totally didn't call that one. Hope y'all are sitting down right now because this one is going to be big. How big, you ask? Well, you might just be talking to the guy who negotiated a deal to make all of the light-up color-changing vapes that Cool Dad is going to give away on this year's global tour. Dang, am I right? This is a huge deal for us. Literally millions of these are going to be given away. Looks rather straightforward. We got color values in, then we control some LEDs to get the shade we want. I put a bunch of extra LEDs in the prototyping bin too, since those should be fun to play with. Okay, cool. This will help me with, I need LEDs for my game. I have some ideas for what I want to do here, but I'm not ready to commit to that just yet. Well, I've committed to it, but I'm not ready to actually do it. Extra LEDs. Little tip for you. See the little triangle at the beginning of an XBus data packet. That's when all of those values in that packet are coming in. It's not like it's one per time unit. Yeah? Okay, yeah, so I learned this in Little Help, where you wanted me to send 3 packets in 1 tick, and I tried to send them in 3 ticks. Shame that Cool Dad's actual music, if I can even call it that, sounds like a 2008-era dubstep crossed with a parliamentary debate if Parliament were populated entirely by screaming macaws. I have no idea why he's famous. My girlfriend Xiaomei is a fan. Some of it is quite danceable. So this is... What is it, like 2047 or so? What's the year? I knew the year once. Let's learn it again. 2026, okay. So not that far in the future. Wait, hang on, 2026. Yeah, that's only 6 years from now. We're already living in the future. That's right. Okay, anyway. Sure. What are you? Okay, so you're a, something 901. Did a real good job at making the 901 part memorable, but not the rest of it. Pingda. Chengsheng. I remember those. Where is that thing? Right down here. C2S RF901. Okay, so that's what this is. But what are you? You're immovable. I can move you, but you're just where you are. Part not recommended. No parts recommended. So this is the LED module, right? So color changing vape pen. Radio RX is a non-blocking X-bus input connected to a radio receiver. Red, green, and blue are simple outputs connected to an ultra-bright RGB, tricolor, LED from top to bottom. When a data packet is received over the radio, pulse the LED as specified. RGB duration, okay. If a data packet is received while a pulse is in progress, interrupt that pulse. Okay, and a duration. Okay, so red value, green value, blue value. Wait, the duration is infinite, I guess? And all 4 of those are going to come in at once. Okay, yeah, so this is an infinite duration one. This one will actually end, but like this will interrupt the infinite duration one, sure. So do I have... Alright, something audio, something that... Ooh. Prototyping only. Ah, I can't remove the sticky notes! Pricing. Oh, okay. Can be obtained, purchased as an MC6000 microprocessor today for prototyping only. Math coprocessor 4010. Ooh, division! So this is how you get a divided. Oh, we get modulus! Modulus and remainder. A little different, I guess. Square root! Whoa! Some real power here, wow. Okay, this is for prototyping only, though. So I guess it's real expensive. Now, hold on, I want to know about the MC4010. Well, it won't let me use it here, but like... Hold on, you've piqued my curiosity. This is prototyping. Yeah, MC4010, neat. And a whole bunch of other stuff, yeah, stuff I've never even seen. So LED modules and stuff. Okay, so LX300 RGB is the thing I'm working with there. Don't know what those are. Alright, I already forgot the name. LX300 RGB, was it? LX300 RGB. Well, that doesn't exist. Alright, never mind. I guess it really doesn't matter. It fully describes itself in the, this. So this is red, this is green, this is blue, I guess. From top to bottom, yes. Okay. Alright, so this program's gonna be like super simple, by the way. I suspect all it's gonna take is, these are simple inputs, right? Okay, now hold on. So I got a pin count slight issue here. So this is all X-bus. I can use the DX300, but it's not recommended, and it wouldn't really help me since these are not just 0 and 100 values. These are continuous. So, since those are simple I/O pins, the cheapest theoretical cost for this is 2 of those, since I do need that many simple pins. Alright, pulse duration. Now, let's be very aware. I should be able... Let's see, I'm not transmitting anything. I should be able... No, it's non-blocking, so I can't sleep on that, right? Alright, so you're going to be the controller. You're going to be the helper. This X is going to go over here, so that's how you two will communicate through X1 both ways. P0 on you is, okay, fine. put you a little off center then. P1's gonna have to, nope, still gonna have to do this. Because I need a bridge in here. But then P1's in the way. Okay, so, boy, wiring. Being an issue, huh? Okay, well I can do this. X0 will be unused. P1 goes somewhere, somehow. Yeah, this barely fits. It doesn't fit. Hold on, but P0 is doing nothing? What am I doing here? So I need 3 simple outputs. Yeah, the annoyance here is that I don't have a microcontroller with 3 simple pins. They only come with 2 each. So I have to improvise something. For this to become possible. Those little things are in my way. What do I do about that? Can I rotate a bridge? It doesn't seem like I can. It also does seem, though, that I can do this. Just bridge the other way, of course. Alright, that works. Clean up those wires. Sure. In fact, let's clean up those wires some more. In fact, let's center things a little bit. There we go. That's pleasing enough. Okay, so P0 on U will not be used at all. So I need to first, both of you, you're going to SLX X0, you're going to SLX X1. So both of you wait for some kind of input to change. However, this is non-blocking, so that'll never... Hold on, but it's non-blocking. Yeah, which means I can't do that, doesn't it? So when can I? Like, when's this actually useful? Until data is available to be read. So like, no, hold on. All right, here. I'm gonna do a ridiculous test here. Oops. Like, this is going to just, yeah, gets negative 999, gets 0, gets negative 999, same tick, can't sleep at all, so yeah, there will be none of that. Okay, so now I know. You, however, can sleep on the input from this. So this one will have to pull, but this one can sleep. So I can save half of my power budget at least. All right? Well, not half of it, but, you know, some of it. So really, this is going to be pretty simple. I said that before. That doesn't necessarily make it true. There, centeredness. Or I could get shortness by doing this. Sure. Alright, so anyway, Rx. You're going to get first red, green, blue, and then a duration. Sure. So I guess the point of the interrupt thing is that I can't just like get this value and then sleep for that long. I have to continue polling. Alright, so move Rx back. When a data packet is received over the radio. So I guess I just have to check. Hold on. Yeah, when I get one and need to test it, I do need to hold on to that. So I can't just like test X0 against Rx. What's Rx? Oh, that's Rx, but it's connected to the X0 pin. Tech, ac, negative 999. Yeah, so I can't just tech x0 negative 999 because that would potentially consume the 0 that I need to hang on to. Alright, so if it's not that, then this is the red, move that to P1. And then you want to move x0, x1. Move x0, x1. That's the other way around. Sure. I think that's all you're ever going to do. Okay, so you send, like, the signal for the color to send is sufficient, because that opens the I/O line, wakes you up, and then you read 2 values in a row, because you're sending 2 values in a row. Now what you need is some sleep logic. How will your sleep logic work? I guess it could just be... oh, how will this work? Oh shoot, I don't have enough instruction space here. There are things I can do about that. Okay, so when... Alright, so I need the duration for one thing. So here's the duration, going into ACK. Okay, now here's where it actually gets kind of tricky. Oh. No, that's no good at all. Okay, so I need an MC 6000 for instruction space, but I also need one for another register. Because I have to use ACK for checking if you're actually transmitting me anything. And that would clobber my my duration that I want to also store there. Now I do have a free register here. What if you were the duration controller? Okay, let's explore that for a bit. So you get 3 packets, and we're going to have some bidirectional communication here. Are we? Is that really what I want to do? So here's the thing. I can't do a hybrid SLXX1 and also sleep until ACK turns... Well, I can't sleep at all until ACK turns to 0. But it's... Okay, well... So I'm gonna have to poll again, so I can't sleep here. Well, but if one is polling, then I want that one that's polling to do all the work here. Okay, so here's basically where I decide, you know, I would keep going down this path if I wanted to strictly go for cost efficiency. I don't. I want to go for power efficiency this time. Alright, so pin type mismatch, I understand. X2 is now what x1 was. Yeah, pin not connected, don't worry about it. That's the wrong type of thing. Alright, so x1 is this. x0 becomes x1. x1 becomes x2. x0 becomes x1. p1. So simple pins just keep their output, whatever is put on them until something else is put there. When the pulse ends, those all do have to be set to 0, so there's actually kind of a bunch more logic that I need yet here. You can go away. Yeah, alright. Let's do this. No, let's not. That doesn't make sense. Because yeah, control flow in this language just doesn't feel great. If I put in a jump instruction, then that's a line that I consumed in this most precious of resources. So anyway, what's my next step here? I need to store that duration in that. So R goes here. G and B go here, which you use to... Is there some other way I can just, like, split up those pins, I wonder? Maybe. But I don't really have a good way to do it. Anyway, so I've put that into the DAT. So in the main loop, yeah, alright, so that's fine. Can I assume I'll always get a duration greater than 0? I'm going to. If the test data gives me a 0, then I'll add extra handling for that, but let's assume the duration is always greater than 0. So all it really is it sets a timer for this to expire and settle its values to 0 if another command hasn't come in first. Okay, so here this is going to loop. So regardless of whether you've gotten a -999 or not, I want to... Ooh, I can't sub-dat, can I? No, I can only operate on ACK. Okay, so then why would I... So I'm going to reverse these. So DAT is the one that's going to get the... Sure, the data. The data from the radio. ACK is the one that's going to keep the... the duration remaining, because I need to operate on it. Sub 1. So at exactly 0, I'm just going to tech ACK 0. I'll let it keep on subbing. Ooh, that's not good, is it? Do numbers wrap? No, they clamp. Okay, so hang on, I can test this. Yeah, numbers clamp. So if I subtract 1 from -999, I don't get 999. Otherwise, what I was about to do would have misfired once every around 2,000 ticks. 1998 ticks or so. Alright, so when this hits exactly 0, then I want to move 0 P1, move 0 x2, move 0 x2. So that's a little bit inefficient if an instruction... Okay, I can make it more efficient. I was going to say it's a little bit inefficient if a new instruction comes in exactly when the delay expires. That's not going to happen commonly, so I think it's better to leave it like this. than it would be to put in an extra jump. Okay, so I would always sub 1 from AC. That's going to happen regardless, even if there's nothing going on, which is unfortunate, but that's how it is. It doesn't make sense to do a test if it's greater than 0 before I sub 1. Does it? It might. Depends whether I expect to spend more time with a light on compared to light off. So I don't know. Anyway, will this work? I think I'm missing some stuff, like a sleep, for example. Alright, let's see how close I am right now. Sure, that went to -1. That's as expected, so nothing's happening. Good. Sub 1 went to -2. Yeah, so this is just going to count down always. Alright, so dat is not -999. There is data, so I read the 50 and put it there. Did you do it? No. You moved the wrong register, because I forgot to update that line. Dat is 0. Why? Because 0 is the output value. That's as expected. Okay, it didn't change because it just happened to already be 0. Okay, here come a 50. That 50 goes here. Check it out, it's green. Halfway green. Check it out, it's cyan, kinda. What's happening? You're waiting for 3 values. Why? Because I wrote this in anticipation of you controlling the timing, but I never actually did that. Okay. Okay. This is encouraging. And yeah, you are managing to just stay in sleep state until you are needed. So again, that's half the power inefficiency from polling averted. Let's just advance. I think I did it. Alright, well the program at least works. The cost is acceptable. I'd rather have stuck with another MC4000. Okay, this is what everybody did. Naturally. Can be done with less power, with some efforts. Can be done with less cost, with a lot of efforts. Can't be done with fewer lines. That figures. Alright, sure. Greetings all. With every project we take, there are factors we can control and factors we cannot control. We could not control the fact that Cool Dad was arrested and jailed for possession of amphetamines as he attempted to enter Japan, thus cancelling the world tour. However, there was something under our control, and that was the terms of the deal. We could have negotiated a better contract that would have allowed us some recourse if something like this happened, instead of leaving us on the hook with 100,000 useless color-changing light-up vapes for us to dump at basement prices just to get rid of them. Well, okay. So she sees us as having made a business error there. Got it. Alright, well, I mean, I'm satisfied enough with this. Let's just take one more little look at it and say, if I wanted to optimize for each axis, every one of these instructions is strictly necessary, I'm pretty sure. So yeah, lines of code is not going down. There's a reason I'm at the bottom of that graph, and so is everybody else. So for power usage, I don't feel like I have a good handle on how to optimize for power usage here. I mean, it's just like optimizing cycle count in TIS 100, basically, just with the weird sleep system in there. So let's think about that for a moment. I mean, I feel like it's going to be something non-obvious, like putting a bunch of these in and parallelizing somehow. Like having two SLXs. Like if the red pin was controlled by one of these and it was sleeping, therefore I would... No, it doesn't look like that would change anything. By involving another one of these, I would only increase power usage. So now that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So to get the cost down, obviously I would ditch this, put a 4,000 back in there, and share some responsibility between these two. Presumably having this one like send commands to this to check on the countdown timer, and have this be responsible for that, because I have 6 instructions to spare here. I don't know if that'd be enough to really handle that, but I do have the spare register, so yeah, I don't need this register if I can use this one. Let's see, so a simple pin. I don't know. I mean, I'm satisfied enough with this. There are no, like, easy low-hanging optimizations to do here. If I really wanted to get stuck in, I'm sure I could get both my power usage and my cost down. But I don't feel like doing that. Okay, so I'll just be satisfied with the conventional solution for that. Alright, I'll see you next time for device 2827.